Welcome to today's episode of PWGC's Environmental Echo Podcast. Joining me today is PWGC President and CEO Paul Boyce and Senior Engineer Dan Sergison, who will be discussing geothermal energy today. I'm Nick Anastasi, Marketing Director at PWGC. If you'd like to listen to this podcast at a later time, you can go to our website at pwgrocer.com/podcast or look at our social media. Gentlemen, welcome to today's podcast. Today we're going to be discussing geothermal energy. And if you could just very quickly explain to our listeners what that means.
Yeah, sure. Good morning, and thank you, Nick. Dan, I'll jump in on this one just to start, and we'll get you in this as soon as possible. But geothermal energy, it's, no pun intended, it's a hot topic lately. It has been for a while, and as, things become more sustainable, people are looking for alternative energy. This is one of the forms that people are starting to really grasp onto, investigate, and have really expressed an interest in. So, you break it down, geo and thermal, right? Geo meaning earth, thermal meaning heat. So it's geothermal. It's like basically the earth, heat, energy type of thing. So essentially what we're using is the earth, the ground, right, and the groundwater as a heat source and a heat sink for heating and cooling of buildings. There's many different types of geothermal, but the one we're actually using, it's more of a ground source heat pump type of application as opposed to like hot rock geothermal, which I'll just take a second to explain that. That's if you drill down far enough into the earth, you're going to get like superheated water, right? Real hot stuff, superheated steam.
Hot springs.
Yep, and you'll bring that up to the surface, that really, really hot steam, to turn a turbine, all right, under pressure, and that generates electricity. That's also a geothermal energy type of application. But what we're going to focus on today is that ground source heat pump, a geo exchange, if you will. Like I said, we're going to transfer heat from the earth into a building, or vice versa. We'll take that heat out of the building to cool it and put it into the earth. Okay. So essentially that's what we're going to be, the basis of our discussion today is, what different types of geothermal systems are there, how they're applicable, who uses them, some of the efficiencies you can get from them, why people are looking at them from a sustainability standpoint and energy savings and all that other fun stuff. Dan, you want to add anything to that?
Well, thanks for having me. And I guess just to add to that, geothermal systems, specifically using ground source heat pumps like you just mentioned, they fit really well with our hydrogeology on Long Island. The operating temperatures of a geothermal heat pump are essentially within about 40 degrees Fahrenheit, 80 degrees Fahrenheit, depending on the time of the year, which we'll get into a bit. But Long Island has generally a temperature below grade of about 55 to 60 degrees, so we're right in the middle of that range here.
So in essence, the average temperature, that 55 degrees, whether it's the summer or whether it's the winter, is what enables this approach to work and for facilities here on the island. For argument's sake, if you begin to, and I know we're going to get into the details of how these systems work and how they go into the ground, so to speak, but to look at these systems and say, okay, if we bring that 55 degree temperature, is that correct, to the surface, and it's the summertime, that's wonderful because you can use that to cool a facility. And in the wintertime, you can bring that up and you only have to heat it up a certain amount to enable it to heat the facility. Am I correct in that?
Dan?
Yes, I would say so. The beauty of the heat pumps is you can heat and cool with 55 degree water. It does change throughout the year depending on what type of system you have, which we could get into, whether it's an open loop or closed loop system. Closed loop systems generally have to pay a lot more attention to the temperature of the fluid in the pipe that you're circulating between the equipment in the house or the building and the heat exchanger that's buried in the ground.
Okay. Now, before we get into the specific types of systems, Paul, we had a podcast not too long ago that discussed issues related to groundwater. Do these systems necessarily impact groundwater here on Long Island, since it is, we are a sole source aquifer, and obviously, it's very important that we maintain and protect that resource. Do these systems impact that water in any way?
They have the potential to if you don't install and operate them properly. One type of system is an open loop where we actually use groundwater. We're going to pump the water out of the earth, groundwater out of the earth, into a building through, like, say, a heat exchange device and then back into the earth. So if it picks up any contaminants once it goes into the building, say there's a leak with the building side, and there's any type of refrigerants or coolants or whatever, antifreezes, that sort of thing, and you pick that up and put it back into the earth, certainly, But, there are ways to mitigate that, by having separate building loops from the ground loop, countercurrent, non-contact heat exchangers. Obviously, we're not mixing the waters. You need, and you've got to operate it effectively. Make sure you're not losing pressure, temperatures staying. There's a whole bunch of ways to see if something's going wrong, if you're maintaining it. And the other thing is to make sure you're designing it properly. Now, the other side of things is a closed loop. Right. We're not pumping groundwater. We're circulating a fluid inside closed, like, black polyethylene piping. That's very similar to the piping that you might see in a front yard lawn sprinkler system, below the surface there. That may have in it not just water, but it may have some sort of, antifreeze type of solution, because when it's in the winter, we're cooling that stuff down, we're taking heat out of it, and it can get, you don't want it to freeze, you don't want it to get viscous, stuff like that. And if those pipes leak, obviously, it would go out into the, subsurface, make its way into the aquifer system. And again, you can keep an eye on how it's operating through pressure, temperature, flows, that sort of thing. But the big thing with that is, quality control while you're installing the system. Right. Make sure you're installing it right. It's a liquid tight system. Once you put it in the earth, as long as it's not disturbed, that stuff is basically inert plastic. Right. Nothing should happen to it. We put it below the frost line. As long as no one digs it up or goes down and hits it somehow, it should not leak.
Okay. And Dan, are there any regulatory requirements that are associated with getting approval for these systems?
They're starting to catch up to that. I know in Suffolk County there's a geothermal model code that the town goes by. They don't necessarily enforce it, but we try to stick to that model code when we design these closed loop systems and open loop systems. But for example, I know they want them, like, say, 10 feet from the property line, a few feet away. I believe it's 25 feet from on-site catch basins, septic systems, stuff like that.
Okay.
There's an important one, I believe, if you want to do an open loop system, say, out east, you need to be at least 100 feet away from somebody else's existing supply well, whether they use it for irrigation or it's unlikely they use it for drinking water. But regardless of the purpose of a neighboring well, they want to make sure that these systems are spaced out between lot and lot.
Okay, understood.
Let me just add to that, there are some regulations at the state level, like if you are like an open loop system on Long Island, if you're going to go above 45 gallons a minute in how much water you're withdrawing, you need a Long Island well permit. There's also the Department of Mineral Resources at the state level. If you do a geothermal system that's over 500 feet deep, you've got a permit with them, whether it's open loop, closed loop, a standing column, any type of system. So there is some state regulatory stuff, but in terms of, how much water can I pump, how many boreholes can I put in, there's really no regulation on that. As Dan mentioned, there is some model code where it dictates, like, setbacks between, say, the property line and sanitary systems and a few other things, but it's not overly regulated.
Understood.
And the state also, just to throw it out there because Paul had mentioned it, the antifreeze that you would put in, say, a closed loop system, that is dictated by the state. So you could do, like, propylene glycol is a common one. There's methanol, ethanol. There's other ones that New York does not allow, but it's a state-by-state thing.
Understood. Now, in the application of this technology, I know that we at PWGC have worked across the region from, for argument's sake, from Manhattan to Montauk. Can you guys tell me how this technology is applied? I know that we've done some work in New York City for some significant projects, and we've done some work out here on the island for some significant projects. Can you explain to our listeners how we apply this technology in those differing regions?
Sure. Dan, you want to start? Go ahead.
Sure. I mean, I guess I'll start west and work my way east.
That works.
Starting in Manhattan, I know we've done back in 2014, 2015, St. Patrick's Cathedral, which I believe we will have a dedicated podcast to at some point in the future. But the way that system works, it's a standing column well system.
Okay.
There's 10 standing column wells surrounding the existing cathedral. They're all different depths. They range from, I believe, 750 feet, the shallowest one, all the way down to 2,200 plus.
Correct.
And I remember I was actually out there, part of putting the drawings together, but also doing a lot of the oversight, because that's very important, just to make sure you see the drilling in action, see how the contractor's installing everything. But I guess the short of it is, a standing column well, it's an open rock borehole. Contractor will drill one of those 10 wells from, where you stand at the church level all the way down as deep as 2,200 feet, like I mentioned. That borehole throughout is, I believe, 10-inch diameter from top to bottom. And then there's a PVC pipe. It's called a shroud, 6 inches in diameter, so it fits within that borehole that was drilled. That 6-inch PVC has perforations, 1-inch perforations in the sides of it, only in the lowest about 100 feet of it, maybe 50 feet of it, to allow water to pass through it. And then, just for argument's sake, you could put a 4-inch diameter submersible pump and motor within that 6-inch PVC. So if you could picture it, you turn this pump on, it's going to pump groundwater up to the mechanical room of the church through a plate frame heat exchanger. And then it's going to come back in a return pipe. And this return pipe goes in what's called the annular space of the standing column well. The annular space is the very narrow space between the 8-inch drilled hole and the 6-inch PVC. And then once that water gets returned below the water table, 100 feet down, maybe deeper than that, that allows the water to go all the way down 2,000 feet, whatever that specific well is, and then goes through those 1-inch perforations in the 6-inch PVC and comes all the way back up to the pump and repeats the process. And at St. Pat's, they have a series of heat pumps, chillers, all different kinds of equipment, but essentially it's using those 10 wells. The mechanical system in the church is using those 10 wells to heat and cool simultaneously throughout the year.
Okay. Now, on that type of system, since we're on the standing column well, actually, I think this question would probably apply across the board, is what does applying geothermal technology to the heating or cooling of a facility allow you to remove from a given site? Do oil burners, other types of internal infrastructure in a facility, does that free up space? Does that enable lower expenses for energy costs? Please get into that and discuss.
Oh, by all means. You could start with the cooling side of things. A lot of facilities may have a cooling tower, right? You've seen those things. They're outdoors, obviously. They're up on a rooftop, or they could be on the ground. But let's say a building in the city, it's generally on the rooftop. They're large, they're noisy. They generate a lot of vibrations. They often at times will have those vapor plumes coming off them. They are known to be, issues for Legionella. And that could be a whole nother podcast, but that's
I wasn't going to go there. But
no,
I was thinking
that's a bacteriological problem, and they also a lot of energy to run those things. There's pumps and fans and all that fun stuff, and they can make noise too. All right, with the fans. With the geothermal system, you remove that. You get rid of all that mechanical equipment associated with it. You get rid of that Legionella risk, the noise, the vapor plume, the vibrations, the space it takes up. So it's aesthetics. You don't have to see this thing. Everything we're doing is below the ground, is out of sight, out of mind. You can build stuff over the top of a lot of these geothermal systems, and then you talk about the energy efficiency. The geothermal system's a more efficient energy system as well. We're going to use less energy to do the same type of, essentially the same thing, cool.
Right.
And you talked about, oil burners, or what we would call boilers, or, heat, whatever type of heating equipment. It's the same thing. We can get rid of or remove a lot of that stuff or replace it with geothermal systems. So again, now we're inside the building. The mechanicals, you don't have that mechanical space. Again, using a lot less energy. We are not burning a fossil fuel, like a gas or a, I'm not going to say coal, but oil or something along those lines. So we don't, less carbon emissions. the benefits of the geothermal system are many over those types of traditional or conventional heating and cooling systems. Now the other side is what's the drawback to geothermal? Oftentimes it's the capital cost. It may cost a little bit more, sometimes a lot more, to install a system like this. As Dan was pointing out, we could be drilling very deep holes in some very difficult places. And it's the price per foot for drilling, and it can be difficult, and as I said, a little more expensive. But then you look at the energy savings. Sometimes these systems, if you run them right, you can see 30, 40, 50, 60+% energy efficiency over your traditional systems. So you look at, what's my return on my investment? When do I break even versus the capital, the more money I had to pay to build this thing, and then when am I in the black here? What am I saving? And that happens. It depends on the system, the difficulties with installing it. And these payback periods can be anywhere from a couple of years to 10, 11, 12 plus years, depending on the size and magnitude. So that's the drawback generally, and also it does take up a little bit of space, in the ground, And I said we can build some stuff over the top of these things, maybe like parking lot. A lot of places in the city now are trying to build buildings over them. If you have an open loop system, you have wells with pumps, as Dan described. You don't want to put stuff over the top of them, because we are going to need to access those wells eventually. It's a mechanical device down there. It's a pump. It's not going to last forever. We've had some systems on the east end of Long Island that still have the original pumps from, 20 plus years ago at this point. Blew my mind, But eventually, a mechanical device is going to fail. So same thing with any of your traditional boilers or condensers, chillers, whatever else devices are going to be in a building or a cooling tower even. Stuff's going to wear out, break down, and have to be replaced or repaired.
In our experience at PWGC, I know we have both analyzed and designed systems for across the region. But one of the things that I think that we should touch on is the importance of assessment in terms of determining the applicability of a geothermal system to a given facility. Can you guys delve into that?
Sure. We one of the services we offer are geothermal feasibility studies, where we would essentially take a look at a proposed site for a client. We would think of a lot of factors go into it, but mainly, what are the heating and cooling loads of the building? Where's the building physically located? How accessible is the groundwater? What is the quality of the groundwater? How accessible are drillers to that area? The permitting requirements of that specific area. I know we touched on them a little bit, but it can change based on where you are in the state, but across the U.S. And we take into account weather data, a couple of, the construction of the proposed building, a lot of things even beyond that. And then the outcome of this exercise would be, which geothermal system is best for your site. It could be a standing column well, like I described, St. Patrick's Cathedral having. That's commonly found in New York City because of the geology. There's a lot of competent rock there. That's what you want to install a standing column well in. But there's also the open loop systems that have supply wells that pump groundwater, diffusion wells that return that groundwater to the water table once it's passed through the building, and the heat exchanger. And then there's also the closed loop systems that, they're a little more bulletproof than the others, as you don't have to worry about water quality so much. And you have more control in those types of systems. So the design process for the closed loop systems, you have to, there's a lot more design work involved in that, in terms of balancing the heating and cooling loads. For example, if you have a facility that has a lot of cooling dominant facility, you use more air conditioning over the course of a year than you do heating. With a closed loop system, over time, if you don't balance those loads and you continue to, cool your facility all summer, into spring and fall as well, and then not heat it so much during the winter, the ground temperature that your system is installed in, the ground will literally heat up over time, year after year, to a point where your air conditioning will stop working at some point. So our geothermal feasibility studies kind of cover the pros and cons of each, but we'll also kind of custom fit for the client what would work best for them, both in terms of efficiency and practicality, constructability, return on investment, the financials of it as well. So there's a lot that goes into determining what is best for a facility. And a lot of it does have to do with the purpose of the building. What are they going to be doing with it? Will it be changing over time?
Right.
Things like that even the client may not know right off the bat. So,
Are there instances where this technology is inappropriate for application?
Nick, I was going to jump in and say it's not one size fits all.
Right.
The Earth isn't a black box. We have had clients that want to, build a significant structure on a piece of property that's, I'm not going to say postage stamp size, but it's pretty small. There's literally only so much load we can get into the ground before, like Dan said, things start to become imbalanced, or we just can't do the entire facility. We look at maybe just a partial geothermal system and combine it with some of the traditional stuff and make a hybrid system. But there are times where you may have constraints where this just isn't going to work. Let's just say we don't have room for a closed loop, standing columns out because we don't have a rock type of situation. Then we would look at, water quality. For an open loop, and you just may have absolutely water quality that's not going to work here. You might have a lot of dissolved iron or manganese, or there could be other issues. There could be contamination nearby that's affecting you. That's as we say a showstopper, right? Dan, a game over. That we would tell the client, this is not going to work. Don't do it. Even though they have their heart set on being, environmentally responsible and sustainable, and they're looking forward to an energy savings, but there may be reasons that this is not a good idea to do. Otherwise, there could be other reasons, like there could be neighboring geothermal systems right next door. They could be surrounded, and they're in a thermal plume. What am I going to do then? As we said, it's a little bit unregulated in that respect. It's like the Wild West, the pioneers, the first guy to get there to stake the turf. Can you go deeper? Is there room to go deeper? What's the geology like? There may be geological conditions. We may have just clay or something that's not going to produce water, or not be very good for, say, like a closed loop system. So there are reasons to this may not work, and that's what you try to vet out in this feasibility study process as well. What are the constraints? What's going to make this thing a non-starter? Also at this point, you also look at the payback period, and the client's got to know the economics involved here as well to say, is this going to work for me?
Right. Now, how adaptable is this technology? Could to up to this point, we've been discussing its applicability towards, say, a single facility. Could this be utilized in for argument's sake, a subdivision where it would heat and cool a multitude of homes, or a large apartment building? I know we've discussed the commercial aspect, but how does that work? Does it work for those types of developments?
I would say definitely. Again, it's on a case by case, not one size fits all type of basis. Okay. But that's something that is currently happening across the U.S. It's definitely happening across the world. I know Sweden does that, where they have district heating and cooling, much like you pay Suffolk County Water Authority here for drinking water. You do the same thing in Sweden for heating and cooling, and they call it a campus system or a district-wide system. We're involved in a couple of them with some of our clients.
Yeah, we've done campus systems where it heats and cools multiple buildings. We're looking at a few more. It's totally doable. It is being done and has been done. And as Dan said, sometimes it gets set up as a district system, or almost like a utility company.
Right.
Very interesting.
And we have one client in particular that comes to mind. They would like to use geothermal heating and cooling across their whole campus. They don't have the money to do it, to renovate all their buildings right now. So they have asked for kind of a roadmap to get them there, where they'd be willing to do construction on maybe one or two out of the dozens of buildings they have in the short term, and we would be able to work with them to ensure that once we have those two buildings done, that we have adequate means to hook up future buildings to that same loop, to speak in closed loop. This is a closed loop system for this client. So if you could picture a lot of buildings, and wherever they have open space to drill or to bury closed loops, they would have those sprinkled throughout where they can. So the more diversity you add to a system, in this fashion. If you can have a building that's cooling, another one that's heating. The more diversity you add, the better the efficiency, because you could essentially share your energy between buildings without pumping it through the ground at that time, and then you do have the ground to temper the fluid and the temperature that's going through those geothermally connected buildings.
Okay, so there is adaptability. There is the ability to, if you put in a given system in the future, it could be expanded if the land and/or acreage is available to allow that to happen.
Definitely.
Okay, and then from an expense perspective, Paul, you alluded to it before. Is there a general number where so this is tends to be the initial investment tends to be more expensive than traditional systems, heating and cooling systems. Is there a percentage? Is it 10% more, 5% more? Is it project based?
It's really project specific, and it's hard to answer,
Okay.
because each site is unique. Each client and owner has unique conditions. So yeah, I mean, it could cost sometimes almost the same, all right, and it could cost sometimes almost double.
Okay.
So there's a wide range, and it depends on a lot of variables, and that's why you need to do your homework up front to figure out what those variables are and what that cost difference is, what it means in terms of cost difference. Is there any? And then the big thing is, okay, great, we run our energy models. How much less energy am I going to use to heat and cool
Right.
this facility or facilities? And then you compare it to the traditional, and your electric and gas and oil costs, and you look at what the difference is, and then what my payback period is to make that money back on what I had to lay out initially in terms of capital. And then once that's all recouped, so to speak, it's savings time.
Dan, are there incentives available from agencies in New York State or nationally for this type of development?
Yes, there's both. NYSERDA actually offers a 26% tax credit between now and the end of 2022 to save on your capital costs of the project.
Mm-hmm.
And I believe that goes down to 22% in 2023. And it may go away after 2023. I have a feeling it'll be extended again.
Mm-hmm.
So that's at the federal level, and then that's at the state
level.
And then there's also local incentives. I know PSEG out here on Long Island, Con Edison, National Grid, they all offer different types of incentives to help pay for these systems, both upfront and long term. And there are new players as far as people that will loan you money to pay for these systems.
Understood.
And that's generally at the very local level.
Understood. And I have another question. How does geothermal, or the application of geothermal technology, integrate with other environmentally friendly energy applications? Solar jumps to mind.
Hey, absolutely, Nick. Now you're talking going like that whole. Everyone's got that net zero concept.
Right. That's what I was getting to.
And yeah, of course. The beauty of geothermal is we don't need the wind to blow or the sun to shine. Right. We're down in the earth, and the earth is the earth. Right. For as long as we've been here, and hopefully for a much longer time than that. But on cloudy days, or at night, you're not getting a whole lot out of your solar system. Or on days when it's pretty calm out, we're not seeing a lot of wind. Your turbines may not be spinning, so you're not generating a lot of electricity that way. But assuming that they're working great together, say solar or wind or whatever, and you are generating electricity, that's all we need is a little bit of electrical power, a little electrification to run some pumps. Whether it's a closed loop system, it could be circulator pumps, or an open loop, it might be a well pump. But if we can couple that with a source that's going to actually make its own electricity. You're heading down towards that net zero path, which
That's
is
really neat.
Yeah, a lot of clients are interested in that too. A lot of places are, implementing that, experimenting with that, and trying to make it work. And it's there.
That's excellent.
Yeah, it's very super dependable, like Paul just mentioned. And just something I wanted to mention about that is, air source heat pumps. You probably have seen them a lot lately. Split systems, a lot of people call them. Those are just like they sound, air source heat pumps. When you are trying to cool your house down and it's 90 degrees in July, you want to remove the heat from your house.
Right.
If you have an air source system, the heat is not really going to move that easily from your 90-degree house to a 90-degree, outside air temp. But when you have geothermal, you're still going to get that 55, 60-degree water that the heat from your house will be rejected into, move to the ground. So what I'm saying is geothermal, you get the most efficient type of system when you need it.
Is this all based on and I was a political science major, so forgive my ignorance. Heat goes to cold, or cold goes to heat?
Basically engineering 101, right? Shit flows downhill, right? We're going to go from high to low. That's generally the way things happen.
Okay.
So, hot's going to want to go towards the cold.
So in that regard, that's the basis of this system and how it works. It's a cornerstone. I don't want to say in terms of the heating and cooling.
You're oversimplifying it, and I'd rather have a mechanical engineer in the room to explain this to
Okay.
you. But essentially, we're moving heat around.
Right. I'm just alluding to what Dan is saying in terms of the air versus not being as efficient as the use of the water.
Right. And I mean, what I was really getting at is when you need it the most on the hottest day of the year, it's going to
Be the most effective.
deliver for you, whereas,
His air to air
source.
is it's going to be struggling to
Right.
keep up on those hot days.
And you're going to be using a lot of energy.
Correct.
And that's what really that's the basis of this approach in this system. If correct me if I'm wrong, is to reduce energy reliance, to make us
That's one of them.
get us towards
Sustainability.
get us towards net zero. Right.
yes, yeah, geothermal will, like Paul mentioned, if your electricity is coming from, say, PV on site or a renewable source, you could easily cut your carbon emissions because you're using the ground. You're not using a cooling tower or boiler or natural gas, anything like that. And something else too, I know I mentioned diversity. When you have, I'll use the classic example of, let's say you have an ice rink facility where you're constantly making ice, constantly cooling. You're going to have a lot of excess heat. What could you do with it? You could integrate it with your domestic hot water system. So you could take that heat that's normally wasted and use it to further cut costs on your facility. If you have loading docks outside, you could use snow melt, essentially radiant floor heating if you need it somewhere in the building, but if you need it outside, if you have ADA ramps, if you have a handicap, accessible parking and required, you could put snow melt under there, and that helps get rid of this load imbalance. If you're constantly cooling, you're going to need somewhere to put that heat, and if you could put it, in your pavement or in your ramps where you'd be spending the money to shovel the snow anyway or dump chemicals on it or whatever, you don't have to do that.
In terms of geothermal technology, how can it be applied on Long Island or in the region, and to what type of facilities?
Yeah, Nick, we at PW Grosser, we've applied it to many different types of facilities. They're very diverse, from the small residential home to the large residential home, to office buildings, to industrial facilities, to hospitals, to museums, to churches, to cathedrals. Basically, I don't want to say it's unlimited, but we've done other municipal type applications, police stations or firehouses. Any place that's going to have a heating and cooling load that's not going to just essentially be dominated in one direction. And even when it is, I mentioned industrial facilities. Mm-hmm. We've worked on one where they need cooling 12 months out of the year, and it's geothermal.
Right.
And it can be, and it can be scaled up to meet just about any size facility. There are constraints. You need to have the right amount of land to put something like this in, and the right type of geology and hydrogeology and all that, which we discussed earlier as part of the feasibility. But the types of facilities and the types of owners and clients, it's very diverse. Just schools alone. We've done public schools, private schools, higher education, meaning colleges and universities. It goes on and on and on, and we haven't, as PW Grosser, just been limited to Long Island and New York City.
Right.
We're throughout the Northeast, down as far as like Baltimore area. We've got projects out in the Midwest. And beyond, even at this point with geothermal, and it ranges from public to private, and we're even looking now at a federal level type of application for it. So it's diverse, very, very diverse in terms of, who's using it, who is applicable for. But the main thing is I caution everybody, just do your due diligence up front.
Right.
Make sure you're going through the right steps. It's, as I said earlier, it's not one size fits all.
Right.
We've had to talk clients out of this before, where it was not a good fit, and they basically had the system 90% designed and ready to go to construction.
Right.
And it's not a good situation when we get brought in at that point, but better late than never, I suppose.
Right.
You want to add anything to that, Dan, in terms of who's using these types of systems, who we've done them for?
A little bit. I know I'd mentioned St. Pat's Cathedral, and Nick's earlier question about what do you eliminate on site. I mean, in terms of St. Pat's, if you're familiar with it, they don't have a roof to put anything on. They have the spires. They hardly have any flat roof. So, not to say they didn't have any other choices, but geothermal was a perfect fit for them.
Right.
Both in terms of what they needed, what they wanted to get out of it, the long-term benefits of it. I know that a lot of the piping that gets installed in the ground, they warranty it 50 years. It'll usually last 100 plus.
Right.
And then just to move, I guess, east out of the city, thinking about an open loop site that we have, open loop geothermal at a site that we have in Glen Cove Hospital. There's actually two separate geothermal systems on that same site. One of them is about 650 gallons a minute, serving one part of the hospital, and another is about 200 gallons a minute, 180, serving a different part of the hospital. But the hospital only uses those for cooling, and they only use them during the I guess what's becoming earlier in the year and later in the year with the shoulder seasons. But it works great for them. They were able to eliminate cooling towers by using this technology, and we do have a contract with them where we do go in a couple times a year to make sure they're not pulling in any salt water. We're not seeing any temperatures that we shouldn't be anticipating, and the water table's where we assume it would be, and everything at Glen Cove has been. It's been challenging, but it's it's still doing what they need the system to do there in terms of cooling. And then to go even further out east, we would have, we've done a lot of residential systems out east. Most of them are closed loop.
When you say out east, you're referring to the east end of Long Island?
Yes.
Okay, understand.
Where some of those residences could be passed off as commercial buildings.
Right.
So they're quite large, but as I mentioned, you could get the tax breaks with any of the geothermal systems, but that's the clients out there really enjoy the tax breaks, but they do really also enjoy the fact that they don't have to hear anything or look at anything.
Right.
They don't have the split units I mentioned on the side of the house. They don't have condenser units on the side of the house. Everything in the inside of the building, it's not exactly the same as a conventional system, but it's similar. But everything on the outside of the building is different because it's instead of being the condenser on the side of the house, it's could be a series of closed loops drilled 500 feet, sometimes deeper, but usually we, like Paul mentioned with the permitting, we like to keep it under 500 feet. So that just takes us through the three types, but
Okay.
Open loop, closed loop, not commonly found in Manhattan where you're contending with that competent rock.
Different type of substrate.
Well, I just do want to add, like at PWGC, what's nice about our firm with geothermal systems is we have engineers and we've got geologists. It's almost the perfect combination to work on these types of systems as far as the feasibility, the design, the permitting, certainly with the construction, the startup, troubleshooting. And the list of services that we can provide for these types of systems just goes on and on and on. But again, it comes down to that symbiotic relationship we have at PWGC between our engineering and environmental staff, which is hydrogeologists and geologists and environmental scientists and all the different types of engineers we employ and work with as well. And we also do work closely with mechanical engineers, outside the firm to do the inside portion of the building.
Right.
So we've worked on some really, really successful projects with some really great teams, and There are many more to come. We've got a bunch lined up, and we're really looking forward to getting started on a few of them. And we're also working on some older systems too that need some maintenance, need some troubleshooting, need a little TLC, if you will. It's not set it and forget it. Right. As I've said before, you got to keep an eye on these systems. They are different than your traditional or conventional systems. So even the facility staff, the owners, their folks need to be aware of what these are, how they work. So there's a little bit of bringing those folks up to speed on what this is, and how to maintain them as well.
At what point does PWGC get involved with these developments?
Yeah, sure, Nick. Great question. Generally, we like to get involved in early on as possible. Say, like a developer comes in and he's got a site. He wants to put up, say, like a small residential high-rise type of situation, or an apartment building, if you will. We'll be involved with the architectural team, the mechanical guys. Early on. Do the due diligence, before you get too far down the track and say, yeah, this is the way I want to go, this is what I'm going to do. You don't just go ahead and do it. Get somebody knowledgeable in there to begin with, to go through, whatever necessary testing, investigation, and identify any types of constraints. Mm-hmm. Work on some of these energy models Dan has described, to see, how's this going to work? Is it going to work? Which systems are best for my site, right, or which one is the best for my site, and are there going to be any other issues that might come up down the road? Like I said, contamination, mm-hmm, water quality, water chemistry, all important. Geology, hydrogeology, your site constraints in terms of setbacks, what the system's going to be next to or near to. Identify all this stuff up front as early as possible. So mm-hmm, before you get too far even into the design phase of things. Right. But the key is to get us in there probably as soon as you're starting to identify, this is the type of building I want to put up, this many square feet or this tall, and you're starting to get a handle on what the energy loads are going to be in terms of heating and cooling.
In essence, the earlier the better.
Absolutely.
Yes, and oftentimes the building energy modeling exercise can let a developer or designer know, if I upgrade my glass windows, if I change the orientation of the building a little bit, you could save 10-20% in heating and cooling costs.
Understood. Gentlemen, this was truly an interesting discussion on the application of geothermal technology here on Long Island and throughout the country. I'd like to thank you for a very interesting discussion. Again, joining us today was PWGC President and CEO Paul Boyce, Senior Engineer Dan Sergison, Marketing Director Nick Anastasi. And again, if you'd like to listen to this podcast at a later point, you can visit our website at pwgrosser.com/podcast or follow us on social media. Thank you.